Okay, so this is worksheet 6, number 20, the half-life problem. The half-life of polonium-210 is 140 days. If you start with 20 milligrams, how long until there are 15.46 milligrams remaining? So the half-life formula, after equals pre times 1/2 to the x over h. Some of these are easy, like we start with 20, so that's the P. How long until, so the after is 15.46. And then the question is always, who's x and who's h? Well, x is how long the experiment runs for, h is the half-life. So which one do we know? We know the h, and what is the h?
140.
Yeah, 140. Some people put 210 in there, but that's just the name of the element, so the 210 doesn't really matter to this problem. So x over 140. Please, please, please do not multiply 20 times 1/2, right? Because you got to use order of operations, and you can't multiply before exponents. So you don't say that this is 10 to the x over 140. That's not going to work. Let's instead divide by 20. And I guess you could put that in a decimal if you wanted to. Divided by 20 wouldn't be an awful decimal. But a lot of times we just leave it as that rather than mess with the decimal and let the calculator handle it later. But either way, what are we going to do next? How do I get this?
Natural log.
Yeah, if we natural log, we'll get that out of the exponent. So I'm going to natural log both sides. Because then that x over 140 can move down front. Natural log 15.46 over 20 equals x over 140 times natural log of 1/2. Alright, we're close, because the only stuff left, there's no more exponents. We have ugly numbers like natural log of weird decimals, but those are just numbers, so we're not intimidated by natural log, especially when we got a calculator that we can punch things into. So what do I want to do next to get x by itself? Actually, give me the two things I want to do. Multiply by 140. That'll make the 140 go away. Close. I mean, that's accurate, but what else do we need to do? What's the next step? Everybody by natural log of 1/2. So now we'll just put that in the calculator and see what we get. So now we can just put this in the calculator very carefully, because that's a lot of stuff going on. This might be a good candidate for the fraction bar. 140 natural log 15.46 divided by 20 all over natural log of 0.5. Again, the fraction bar is completely up to you. If things are complicated, I use it to keep things straight. If things are pretty easy and I can get by without it, whatever. Use it every time, use it none of the time. Your choice. 52.004. Generally, we want 3 decimal places. Yes. No, it's fine. On half-life problems, you can also kind of check your answers. If we start with 20 milligrams, then in 140 days, if we start with 0, or excuse me, at time 0 we start with 20. In 140 days, how much should we have left if the half-life is 140? Half-life means how long it takes to be cut in half. So if we start with 20, how much will we have left after 140 days? Are you just not wanting to answer, or do you not know? Okay, what it means to be a half-life is that's how long it takes to decay to half of what it started with. So this polonium decays, it just goes away. Every 140 days, the amount you had is cut in half. So if we start with 20, after 140 days, how much will we have? 10. And after 280 days, so after another 140 days, we'd have 5, and so on. So if you want to, you can kind of lay this out. We want to know when there's 15 left, or about 15 left. Like, well, somewhere between 0 and 140. Whoops, this was days, so that should be days. So my answer, I think, makes sense. It's not linear, so I can't say that 15 is exactly halfway between 20 and 10, so the answer should be 70. It doesn't work like that. But at least you can sort of slot in that after 52 days, that makes sense that you'd have 15 grams left, or milligrams, whatever. So the half-life problem, if you understand what half-life means, you can have a little bit of a check on your answer to make sure that it makes sense. Right? If we'd have gotten 5,000 days, then that wouldn't make sense. So you can do a little bit of a check to see that your answer sort of fits with the problem.